I'm holding in my hand here just an ordinary sheet of copy paper. Did you know that hidden in this sheet of paper is a whole world of geometry? Over the next few minutes, we're going to be folding and unfolding and cutting shapes out of this sheet of paper, and we'll be looking at some of the characteristics of those shapes. We'll even be looking at relationships between shapes. And when we get done, we're going to end up with some pieces, and those pieces are going to turn out to be part of a very interesting, very old puzzle called the Tangram. The first fold we will make is to fold the bottom side of this sheet of paper onto a side. I'm going to turn it so that it's facing me and I can easily make the fold. We'll want that fold to be as accurate as we can make it, and when we make the fold, to make that a nice crisp fold. Before we go on, let's just take a quick look at what we have. We started with a rectangle. We made this fold. Obviously, we still have four sides. This shape we call a trapezoid. It has exactly one pair of opposite sides parallel. Obviously, the other two sides are not parallel. What we're really after is a square. We want to get a square out of this, so we're going to cut off this little rectangle that's not covered up here, that does not overlap. Clearly what we have here again is a rectangle, kind of a long skinny one. We'll set it aside and we won't come back to it. What we're really interested in is what's left here. Clearly I see a triangle. It's a right triangle. It has two sides that are of equal length. We call such a triangle an isosceles because it has two equal sides, right triangle because it has a right angle. Now let's open our triangle, and clearly what we see when we open it is a square. We see a square, we have a fold line. I'm not sure if you can see that fold line, so I'm going to draw a line over that fold so that it will be visible. The line that you see here is my fold line. It goes from one vertex or corner to the other corner or vertex. We call such a line a diagonal of the square. Now let's cut the square in half by cutting along this diagonal line, along this fold line. And when I do that, you'll see that what I get are two triangles. You can see that those two triangles have the same size and shape. We say that triangles like that are congruent. To be congruent is a way of relating two triangles to each other. We'll set aside one of the triangles now. We'll come back to it a bit later. And we'll focus on this triangle in front of us. Let's make a fold, make another fold. This time we're going to fold this corner onto this corner. We call these two angles at these corners acute angles because they are smaller than a right angle. And we will make the fold. You can see that after the fold, what I have here is another right isosceles triangle. It's smaller than the one that we started with here. And you can see the crease line. That crease line is perpendicular to this side, the longer side of the triangle. I'm going to draw a line on that crease so that it will be easier for you to see. We call this line that is perpendicular to this side, and actually in this case goes through the midpoint of this side, an altitude of the triangle. Now we'll cut this triangle in half along the altitude, along that fold line that we just made. And you can see that when I do that, what I have here are two triangles. Again, these two triangles are congruent. They're the same size and shape. There's something else going on here I want you to notice. I'm going to bring back the triangle that we set aside a little bit ago. And you can see that this triangle, while it's larger than this one, has the same shape. They both have a right angle. They both have acute angles that are the same size. So if two triangles have the same shape, but are different sizes, we say that those two triangles are similar. Now we'll set aside these two smaller triangles and we'll bring back the larger one that we set aside earlier. And this time we're going to put the corners or the vertices of the two smaller angles, remember we call those angles acute angles, together. And instead of making a fold, we're just going to pinch. By pinching, I've marked this point along this side of the triangle. I'm just going to make a little mark here so that you can see where my pinch was. So this point now is the midpoint of this side of this right triangle. And now we're going to take the vertex or the corner at the right angle and we're going to fold so that the corner or vertex is right on that midpoint of that longer side of our triangle. And you see that what we get here is a trapezoid again. It's a very special trapezoid because the two sides that are not parallel in this case are equal. We call such a trapezoid an isosceles trapezoid. Now we'll open this back up just like we've done before, and I'm going to draw this fold line so that you can see it. This fold line turns out to be parallel to this line. It also actually turns out to be half the length of this line. Now let's cut along our fold line. And you know what we're going to get. We have another right isosceles triangle and we have our trapezoid. Let's bring back the two pieces that we set aside a bit ago, and let's just do a little bit of a review. Remember that we started cutting these pieces from a square, and when we cut the square, we cut it into two triangles. We cut one of those triangles into these two pieces. Let's put those back together. And then what we just finished doing was we cut this triangle, the second larger triangle, into two pieces, these two pieces. Notice that I can put all of these back together again and get that original square that I started with.